with the theory part which we had discussed in our last class. Today we would be going with the practical exercise. I'm just going to show you one exercise. We will be doing it together, and that will be for call option. Okay, and the next part for how do we go with computation of price of a put option, which you will be doing it yourself using the formula we had learned. Okay, so as we said, Black-Scholes pricing model, Black-Scholes pricing model is used for computation of option price, right? That is the premium. What is the amount which you have to pay when you are planning to buy a call option or put option? We know that the strike price is decided based on the spot price and the risk and time involved in that. Accordingly, the investor also will have to pay a price that is quoted in the by the name premium when he is going to purchase a call or put option. So that's what we go with computation through Black-Scholes option pricing model. Now the answer we get, suppose if we get an answer after computing, the value of C remains to be like 1.22 or maybe 1.55. So that communicates that, yes, this is the price which the investor has to pay for each stock being purchased by him under call option. So for every share, the underlying, assuming that the underlying asset in this case is share, stock. Okay. So if the C value is 1.55, that is actually the price, the premium. We call that as premium in the stock market platform. In the stock exchange platform also, this will be quoted, and it will vary depending on the market conditions, the movement of the price of the underlying assets, and also the option period. It will be different for the same stock itself. Option price can be different when it is related to two different periods. So that's what we compute by using this Black-Scholes option pricing model. So if I'm arriving at a value called 1.55, it tells that this particular investor will have to pay 1.55 per stock for getting that option, for purchasing that right, for purchasing that call option. So maybe the underlying asset, as we know, it is in lot, right? So he might be having 100 or maybe 1,500 as decided by the market. The lot size is decided by the market participants. So they as it is being mentioned, he will have to multiply that with number of stock involved in that particular option. Okay, so that's the relevance. That's what we go with computation when we talk about Black-Scholes option pricing model. Now, we had learned the theory part, the formula. We had discussed it in our last class. Today, we are just looking at how to solve it. Okay, so this is the condition where the current market price of the stock is 20 rupees. The strike price also remains to be 20 rupees. And as here, the risk-free interest rate, that is 12% is assumed to be the opportunity cost or the possibility of risk-free return, that is quoted as 12%. And the variance, here you have to note that it is variance. Variance earlier in binomial and all, we went with taking standard deviation. Now this is variation. So that is the difference which you can find here in a Black-Scholes formula. While learning also, please take care of it. Here we have variance. Variance of return is, it is 0.16. Okay, variance of return is 0.16. And then the model, we are asked to compute the price of the stock option using the Black-Scholes model. Okay, And of course, 3 months. So T in this case would be 3 by 12. 3 months being given as the time period for this particular option. So let's see, and I have just put the formula which we had discussed in our last class here, where we know that S naught, it is the spot price, and N into D1, that is nothing but the value we get from the cumulative normality distribution, which we are going to see how we had already done that in your statistics. And K is the strike price, and the present value component is included, that is e raised to minus RT, and the value for that we would be taking from the anti-logarithm table, and then N into D2. And we have learned how to go with computation of the value of D1 and D2. So let's do it. I've just put the values, taken out the values from the question. S naught here is 20. The strike price in this particular case is 20. So we have put it as 20. K, it is again the strike price. S naught is the spot price and K is the strike price. And R is the rate of return, the opportunity cost or the risk-free interest rate of return, which is 12%, variance 0.16, and time involved is 3 by 12. This is what we got from the question. Now, what we would be doing is we are going with the computation of call option, assuming that in our question, it is an open-ended question. So we are supposed to calculate both the price for call as well as put. Okay, so let's do with call. So as you understand, first we go with the computation of D1, and the formula for D1 I have put it here. Natural logarithm, that is ln, logarithm value of the spot price divided by strike price plus R. No, the whole brackets are very important in this case, plus R plus variance divided by 2 into T, the whole by standard deviation of whole root of T. Okay, so now we go with computation, where we know that the spot price and strike price in this case is 20. So 20 by 20. In this case, computation of logarithm value is simple. Taking up the value from logarithm table is simple, because 20 by 20, it is 1. So naturally, anything raised to 0 gives us 1. So directly we can take the value as 0 natural from the logarithm table. We need not look into the table for this case, because it is directly understood. Anything raised to 0, you get the basis, you get the answer as 1. So in case of logarithm, what we are looking at is the value of the exponential. So the value of exponential in this case, it should be 0. That's why we've directly put that as 0. And then we know that R in this case is 0.12. So we have substituted the values here, and we are given with the value for variance, which is 0.16, right? And that is divided by 2, and the whole is multiplied with 3, 3 by 12, right? Because 3 by 12 is nothing but it is 3 months out of 1 year. So that's why T being expressed as 3 by 12, and the whole divided by standard deviation. So here variance being given, so it is very easy for us to go with finding out the value of standard deviation, the root of, right? So the root of that value, which gives us 0.40 into, we go with computation, standard deviation into root of T, root of 3 by 12. So the whole root of 3 by 12. So that's what we get as 0.50. So finally, we go with the computation. We have substituted all the values here. And as I said, here it is ln is natural logarithm, where the base is e. So Natural logarithm, anything raised, as I said at the beginning, anything raised to um, 0, you get the base and you get the answer as 1. So that is why natural ln of 1 is 0 plus and I have already got the value here which I had done here, the substitution of this. I had solved this equation where I get the value as 0.05, and then I also computed this part where which needs to be this, the solving of this part, okay, this part which I get the value as divide by zero point 0.2, and once I solve this equation, I'm going to get the answer as 0.25, right? What we have to remember here is when we are solving this equation, we need to be very careful with the BODMAS rule, like opening up the brackets and then going with substituting and computing the formula. I mean, computing and solving the equation. We have to be very, very careful with BODMAS rule. Otherwise, it would be, no, we will go wrong. First, we have to open up the brackets. So first, everything what is there in the bracket needs to be solved before we go with opening up the brackets, before we go with solving the rest part. So each part, that's why I put in brackets all of it. It is easy for you if you put it like that, because otherwise you will get confused with at the time of solving it. Okay, so put the brackets correctly, open up the brackets first, and then go with solving the equation. Okay, now d2, as you know, it's d1 minus the whole no, standard deviation of whole root of t, which is just a substitution of the whole thing. D1 we already got the value as 0.25, and then we had solved the same kind, that is standard deviation whole root of t in the previous part. So I just took the value from that. So that is 0.40 into 0.50 is equal to, finally we arrive at the value as 0.05. So now we got the value for D1 and D2. Now we are going with the final substitution of the values in the formula. So we know that as per the formula, it will be the spot price into the normality distribution, normal distribution value, which we take the cumulative value from which we take from the normal distribution table. I have brought the normal distribution table here. You will be having that in your Clark's table, but I've just taken for you to me to show how do you find the value. So we multiply that value with D1, and then of course we have to go with computation of k k into e raised to negative rt. K we know the value is 20 into e raised to negative rt, for which we will be looking at the anti-logarithm table to get the value of it. We already learned that, and then into natural, as you say, the normality distribution value of D2. So this is it, what we are going to do. Okay. And D1 and D2, I have just taken the value here, which we had computed from the last here, from here. So we know that D1 is 0.25 and D2 is 0.05. So these two values I've just taken to the next part. Okay. So 0.25 and 0.05. Now we have to compute the value of n of D1 and n of D2. Okay, so this is something which we have to go with, taking up from the cumulative normality distribution table having a positive value. Okay, that's what we have to do. So I've just put it. This table is there in your Clark's table. So this is cumulative standard normal distribution table. This is there. Maybe at the back of your textbooks also, they normally give this. If not, it is available online, but for the university exam, you have to have a table with you, because you have to take that with you for computing these values. It may not be given in your exam. So in this case, first let us look at n is in where we have to find out the normality, cumulative normality distribution value for 0.25, right? And how do we do is 0.25 is nothing but zero point 0.2 plus 5, correct? 0.2 plus 5, 0.20 plus, that's what it happens, right? So that's why what I will do is I'll take the value 0.20, right? And I will look up at 0.05. I have just put the whole part in a using a marker because you will be looking at that portion. So it will be like this: 0.20. I'm taking up the value which is against 0.05. Why did I do in that way? Because it is 0.2 plus 0.05 will give me 0.25. Right. So that is why what I do is 0.20 plus, I would be taking up the value of 0.05. So I get 5927. Natural logarithm of 0.25 will give me 0.5987. That's how I go with the computation. Now the next is 0.05, right? So again, in the same way, I would be going with computation from here. In this step, I have just taken one example, so I have to go with the previous one. So, so what you have to remember here is when I'm going with the computation of the option pricing, I need to have Clark's table with me. So I have to arrive at the value of logarithm, natural logarithm. In that case, the base would be E, and I have to go with the anti-logarithm. There also for our computation, we went with the computation of value having the base is E, but we also learned how to compute if we have a value with 10 base, or maybe if we have a value with 10 in as in your table with base 10 in your anti-logarithm table. So same way, I'll tell you how to convert if the base, if you have log with base 10 instead of natural logarithm. Normally Clark's table, it is there, but if at all it is not there, I'll teach you how to how to convert that value into base 10 and then look in a table, logarithm table, where the base is 10. All right, that I'll teach you. And now what we will be going with is we are going with the computation of European call option. So we know the formula, we had looked up on the formula. So it will be the strike price into this normality, cumulative normality distribution value of D1 minus strike price into the present value component, which we get from the anti-logarithm into the normality, cumulative normality distribution value of D2. So that's what the formula is all about. And we are just substituting here the whole thing, that is our spot price. Here it is 20 into the value which we got minus 20 into e raised to negative 0.12 into 0.25. Now this is something which we take it from the table, that is from our anti-logarithm table, into this. Once we compute this, the whole into 0.5199. Okay, so we will go with computation of those in the brackets first, and then we will open up the brackets. So here, when I went this with this solving this part, the first part of it, that is 20 into 0.5927, I get 11.974. That's what I get here. And then I went with computation, solving this part. I solved this part first. I took the value from anti-logarithm, and then this is how I get it. Okay, anti-logarithm table, 20 into this part I will get, and then the whole multiplied with 0.5199. Okay, so now I understand that I have to go with solving this part first. I solved it. Then I multiplied with, that is the only thing which you might face when you are doing this. The rest all is substitution of formula and values. But that opening up of brackets and solving that part, I often find that students go wrong. The rest of all would be same. But if you forget to observe the BODMAS rule, even in one case, the whole answer would be wrong. So that is where you have to be very careful when you go with doing this thing, this part. Okay. So what I did is I first solved this part, and then multiplied this with 0.5199. So that's what I did. So I got this part, that is 10.09, and I had already found out the value for this. As far as possible, we can keep the decimal points for 2 or maximum of 3. Otherwise, it will be little confusing for you. 4 is also fine, but not beyond that. Don't go beyond that. 11.97 minus 10.09, and we get the value as 1.88. We get the value as 1.8, is the difference between that. In this case, what you have to remember is this value which I get 1.88 here as C is the premium which needs to be paid by the investor when he is going to purchase in the purchase option from the market. But this is theoretical price. This is something which you have to really understand, and that is why you might have found often the research papers where they say what is the difference, the price trading in the market, the current price trading in the market, and the theoretical price, how far it is different. We call from the perspective of underpriced or overpriced. We have learned that when a call option is underpriced, people feel that yes, it will reach to a stage of the real price, so there is possibility of gaining from that. And if it is overpriced, it's right time for us to sell it. So how do we compute that? The basic computation for that is based on this theoretical price. Market, of course, it is depending on the demand and supply, and that is based on the market movements. So when you compare with the theoretical price, you try to understand whether it is underpriced or overpriced. That's the crux. So that's the logic here in going with this computation, because in stock market they go with a lot of algorithms when they compute the option price. Nobody can crack. Of course, it's based on software, but nobody can predict exactly what will be the option price at a particular spot, or what are the factors that has contributed to the particular price at that moment. There might be many market forces, foreseen and unforeseen conditions. That's something which is based on market condition. Now, what we have learned here is computation of the same thing based on theory. In theory, we know that the factors that will be affecting option price is the strike price, the spot price, the end spot price, that is the period, the spot price at the expiration of the contract. That is why we involve the time factor here in this formula. And we also know that it also depends upon the concept of present value. So we have gone with using all these, and we have normalized. The cumulative normality condition is something which is needed for going with statistical operations, because we believe that things happen under normal conditions, and the price, that's a basic assumption, price move at random. There is no relationship between, or nobody can predict what is going to happen, or there is no as we say, correlation between the price of the previous period. Even though that will not happen in the real situation, there can be some correlation, there can be some moments which can be predicted by studying the past moment. But this is the basic assumption of Black-Scholes theory, random movement. So that is why we assume normality in the computation. That explains the logic of using normal or cumulative normal values for our computation. So that's the logic of going with based on the assumptions we make. And another thing which we have assumed that is there is possibility of risk-free return of 9%, which is very difficult. There is nothing called as risk-free return. Only thing we can compute is based on the opportunity cost of each investor. So that also is an assumption, and maybe because of that, maybe because of these, no, the distance, the gap between these assumptions and reality, the theoretical price might be different from what is there in the market. That could be the reason. All these are based on the assumptions. All these are based on the studies, the researches which has been conducted in this area. So what I would like to conclude is this 1.88 is a theoretical price. Now, when I look into the market, maybe I don't get the same no price, or I am not offered with the same price in the market. Maybe it is little high or maybe it is low. So it is for the investor to identify whether this particular price is overpriced or underpriced, and based on that his transactions and further movements would be happening in the market. So we have gone with learning computation of theoretical price of an option can be called or put based on Black-Scholes model, and that is the charm in this model. That's why it has received a lot of acceptance all over the world, because it will help an investor in identifying the overpriced and underpriced assets, the stock, maybe with respect to stock. And there are a lot of softwares which will help you to compute the Black-Scholes option price, that is theoretical price. You're provided with a lot of softwares with using which you can compute it on every moment based on the fluctuation in the market prices. So when we go with the manual computation, maybe it is lengthy, it takes a lot of time, we have to go with a lot of calculations. But when it is computerized, things are simple. So this is something which we wanted to discuss. We were trying to solve one equation, like one situation where the current price, the stock, the strike price and the spot price given, the risk-free return being given, and the variance that is also given in our question, and the time period was 3 months. Now, I would like to add, which we would be doing in our next class, that is, suppose if you assume this to be two conditions where you're going with the computation of put as well as call price without changing, without assume that this is how it is available. You have a put which is available for 20 rupees, for which the asset is trading at 20, that is the spot price, and strike price being 20. Same, you have a call also that is available with the stock price 20 and strike price 20 and the maturity period 3 months. You can go with solving this using put parity theory. We have learned another formula in our yesterday's class where we went with discussion of put parity theory. So the same exercise we can do for solving that equation, assuming the condition that the market is available with put and call option with the same strike price, with the same maturity, and also with the same value for the underlying stock, same price for the underlying stock. So then we can go with application of the put parity formula to go with finding out what will be the price if the condition is same for call and put. That's what we learned yesterday. We can apply that also, and you will be surprised that you're getting the same answer as we did using this lengthy formula. That formula is little more simple. Using that formula also you can get the same solution, because we are assuming that in this, suppose if as I say, if put is 20 and if call is say 25, we cannot go with the application of that formula. But in this particular case, assuming that there is put parity, Okay, uh, then we can go with applying the second formula which we have learned under put parity theory.